Okay, this is group 33, which consists of Brian Burns, Eddie Corin, and myself, Mike Prochnow. We've been assigned to do problem 11.19 out of the textbook. And so Brian, whenever you're ready, take it away.
All right, we're given a simple frame, which consists of this part right here. It's loaded symmetrically with 18 kilonewtons spaced 4 meters apart and 12 meters across total. The summation of the forces of these reactions would equal 18 kilonewtons upwards in both, and there's no horizontal reactions. And if you section this member BC here and here, the shear diagram would look like this. You can tell it goes up 18 kilonewtons, and it ends, and then it checks at 0. And then for the moment diagram, it goes up to 72 kilonewton meters. And what we're looking for in this problem is pretty much the deflection at E, which is which we labeled the midspan of member BC. And going to this figure, our deflected shape is symmetric in that the midpoint will consist of 0 slope, and they both supports A and D both pan out the same. What you want to emphasize here is that the axial loading at B and C, the vertical displacement is negligible, so we're not taking that into account in this problem. And so we're looking for this distance here, which is delta E. And in order to solve that, we used delta BC, which is the length from the tangent of the position at B all the way up to C, and delta BE, which is the halfway point between BC and B going up to the midpoint at E. And so our final equation is delta E is equal to delta BC over 2 minus delta BE. And I'll pass it now to Eddie.
All right, for delta BE, we found the area under the total moment, or the total area of the moment diagram, which is a trapezoid. For that, you need to take the average of the bases multiplied by the height, which would be 72 kilonewtons, and we have 12 plus 4 divided by 2. Also, you divide by you multiply by L over 2. This is the centroid of the trapezoid, since it's a normal figure. The centroid's in the middle. You do all that, and it comes out to 20,736 kilonewtons, kilonewton meters cubed over EI. Then for delta BE, you only have half the trapezoid. To do that, you sum the area times the centroid of this triangle and this square here. When doing that, you find the centroid is 4.33 meters. And then similarly as with the trapezoid, you find the area times the midpoint of the area. That gives you 3,741.12 kilonewton meters cubed over EI. And then plugging into the equation that Brian described before, we get a final answer of 6,626.88 kilonewtons times meters cubed over EI for the final deflection.